Okay, this is a video going over some of the problems in section 5.5, which is more on logs. And what I'm trying to get at 9 and 10, particularly 9, is a little bit starting to develop some intuition, which we're going to, of laws of logs, which we will learn about probably a few classes from now. And for now, though, we don't know them, so we're going to use what we know about exponents to help us here. So I want to talk about these problems in a few different ways. So let's look first at our given information. So Nicole knows that log base 6 of 2 is 0.3869 and log base 6 of 5 is 0.8982. Okay, so let's, knowing that information, we actually can rewrite that in exponential form. So for the first one, we know then that 6 to the 0.3869 equals 2. Again, changing it from log to exponential form. And the same is true for the other one, 6 to the 0.8982 equals 5. And another thing we know about base 6 is 6 to the 1, of course, is 6. So we know that as well. Didn't need to give you that probably, but all right, so let's look at this first one. I'm saying, tell me what log base 6 of 3 is. Using our information above. So what you want to, first, well, a few ways to do that. First, a lot of people may be comfortable changing this to exponential. So let's just say equals x, and we're trying to figure out what x is. So you would rewrite an exponential, 6 to the x equals 3. And so the idea is, remember what we've done with solving for a variable and an exponent. We've rewritten both sides in terms of the same base. Well, right now 3, of course, is 3, and I can't write that in base 6. But perhaps I can use some of my given information to rewrite 3 in terms of base 6. And in this particular case, we know that 3 is the same thing as 6 divided by 2. And I can rewrite 2 using this piece of information above. So again, the goal was to rewrite everything in terms of base 6. So I could rewrite this right side as 6 over, and 2 is 6 to the 0.3869. Okay, so let's see what we have here. We've got 6 to the x equals this right side, which is 6 to the 1. Over 6 to the 0.3869. And remember what we do when we divide with the same base. We subtract exponents. So 6 to the 1 minus 0.3869. And then the only way this is true is if x is 1 minus 0.3869. And then at this point, you can use your calculator to find that number. So that's the idea. Another way to do this, if you didn't want to initially change log base 6 of 3 to an exponential, is you could say, and it's going to be the same idea, you could say, okay, log base 6 of 3, I want to rewrite 3 in terms of base 6. So log base 6 of, well, 3, we remember we just did was 6 over 2, and 6 is already in base 6, but let's rewrite 2 as 6 to the 0.3869. So we've got log base 6 of, again, same base. You subtract exponents, 6 to the 1 minus 0.3869. So now I think in terms of exponentials, I think 6, if I set this equal to x, I think to myself, 6 to what power gives me 6 to the 1 minus 0.3869. And that lands you with x being 1 minus 0.3869. And again, you can do that on your calculator. So same idea there. Either keep it in the log for a bit longer until you get to base 6, or you can initially change it to exponential and then work to put everything in terms of base 6. Okay, so that's 9. Let's now look at 10, which is similar, but also a little different. Okay, so 2 pieces of information were given. 10 to the 0.301 is 2, and 2 to the 10th is 1024. All right, so let's start by, I'll just say equals x. And because we may be comfortable maybe putting it to exponential. I'll show you both ways in this case. You could keep it in the log and then think about exponential, or we can change it to exponential right away, which some people prefer to do. So log base 10 of 2 means 10 to what power, what I'm trying to find, equals 2. And notice I can substitute 2 with base 10 because 2 is 10 to the 0.301. And so the only way this is true is if x equals 0.301. So if some people, again, like to keep it in logs longer. So you could have just said, okay, log base 10 of 2. Well, let's replace 2 with 10 to the 0.301. And then you're asking yourself, 10 to what power gives me 10 to the 0.301. So really the same idea. It's just at what point you substitute. Do you change it to exponential first, or do you think about it exponentially later on? Okay, let's do another here. Let's do this one. So log base 2 of 10. So I can say 2 to what power gives me 10. And now, again, this is a little different because 2 is with the x, but that's okay. So substitute in what 2 is. 2 is 10 to the 0.301 to the x equals 10. And on the left side, remember, a power to a power you multiply. So 10 to the 0.301x equals 10 to the 1. So 0.301x equals 1. X is 1 over 0.301. So doing it that way. C, I bet you could do C, but let's just get it started. 10 to what equals 4. And remember, we can rewrite 4 as 2 squared. And then you can plug back in what 2 is, which is 10 to the 0.301, and go from there. The same is true of D, because 8 is 2 to the 3rd, so that's going to be very similar. E, the reason I gave you 1024 is you can, actually let's do E. Sorry, running out of room here. So log base 10 of 1024 equals what? 10 to the x equals 1024. And remember, 1024 is, as I gave you in the instructions, is 2 to the 10th. And then I can, once again, plug in what 2 is. That is the other piece of given information. 2 is, remember, 10 to the 0.301 to the 10th. So x is going to be 10 times 0.301. So try those problems. See what you can do with the rest of those. Actually, let's do one more. Let me see which one I want to do. Maybe let's do J, because if you can do J, then you can do K and L. So let's look at J. Okay, so J is log base 2 of 0.1. So, and we want to see what it is. This is saying 2 to what power gives me 0.1, which remember is 1/10. Okay, so now let's see, what can I do here? Well, again, I have 10 on the right. Once again, we know what 2 is in terms of 10, so let's replace 2 with 10 to the 0.301 to the x equals 1/10 is just 10 to the -1. And so then we're going to get 0.301x equals -1, and then you can solve for x. So I bet you could do the rest then. Okay, let's stop it there.